Before we get started on 8.2, just a reminder. So you guys are starting hybrid again next week. So starting Monday. At the end of class, if you'd like, I can open up basically like my attendance book, Inventing Campus. I have a feeling some of you guys probably forgot who's an A day or a B day. You know, like I bet some of you just have no idea if you're supposed to actually go Monday or not. So at the end of class, if you guys would like me to look that up for you, I certainly can, to kind of remind you. And I know it's only Wednesday. I just thought I'd give you guys kind of a heads up, so you don't go into the weekend worrying about it. And nextly, before we start 8.2, does anybody want me to kind of help you with any kind of questions from 8.1? Like, was there any questions you got stuck on that you'd like me to do for you quick? Okay. I mean, if you come up with one, certainly let me know. Today's section is 100% using what we did yesterday. And so that's kind of why it was important that I wanted to help you if you felt like you needed it. So today's is what is going to be called factoring using the greatest common factor. And factoring, let me grab my little pen here. So factoring is a word you're going to hear a lot of. It basically means to be able to write something as multiplication. Because, I mean, you're absolutely going to be hearing the word factoring a lot, okay? And it's really easy to get lost into what it actually means because it's not necessarily a word that you flat out will see. You know, like if you guys are given the directions, or if a section's titled solving, well, you understand that the whole point of that is to find an answer, to solve. So this whole chapter is about factoring. And I know some students get lost on this because factoring can look a lot of different ways. And so it's not like as obvious. So that's what we're trying to do. So if we look at this first example I've got written in orange, 4x squared minus 3x, our goal is to figure out how I can write this information as something being multiplied. And the reason we go through this whole process is because writing something as being multiplied actually is a very easy way for us to find answers later on. But since there's a lot of ways to factor and you know, a lot of things about it, that it takes up like a whole chapter of factoring. So that's kind of our goal. Now, if we want to know how to write this as multiplication, one method to doing this is to look for a greatest common factor, which is what we did yesterday. So a greatest common factor would mean, do these two things have anything in common that's being multiplied? And we can absolutely start this out like we did yesterday. So we're going to take each one of these two terms and kind of break them apart. And we're going to look to see if they have anything in common that was being multiplied into them. So 4x squared, I see right away that I can break up 4 into 2 and 2. So 4x squared could be written as 2 times 2 times x times x. Now 3x is actually pretty simple and straightforward. 3 can't be broken up because it's prime, and there's only a single x. So 3x can only be written as 3 times x. Logan, I'm hoping you can help me start this one out. Do you remember how to identify what they have in common? Okay, you can do it that way. So these two right here, the 2xx and the 3x, what do they have in common? Perfect. They have no numbers in common, but they have a single x in common. No problem, Harun. Yeah. Okay, so for me to write the answer, if I want to write the answer as factored, I'm going to write what they have in common first. Okay? And I'm not going to do this in all the problems. I just thought it would be a good idea for me to write on this first problem what we're doing. In the parentheses, we're going to say what they don't have in common. Okay? So what they don't have in common is a 4x and a 3. And then there was a subtraction symbol, so I'll keep that there. So this is going to be the basic idea of what we're doing today. If you want to factor something using the greatest common factor, this is basically how you will do it every time. Whatever they have in common, you put in the front. Inside the parentheses, you're going to put what's left over or what they don't have in common. That's how you go about factoring. So this is considered factored because we rewrote it as multiplication. Okay, now it's very possible you guys have seen this topic before. I'm sure depending on who you had for your teacher last year, it's very possible you would have seen this. I'm also kind of under the impression that some of you may have never seen this or don't remember any of it. If you guys could give me a quick indication of 0 to 5 how you're feeling about greatest common factor after watching this first one. This will kind of give me a clue as to how I should go through the rest of the day. Oh, that's a lot higher than I thought. Do you guys remember seeing this in the past? Oh. I mean, I've got to think some people don't remember this, but I'm impressed. If you guys remember seeing all this in the past. So, okay. Well, that's really good. So our goal after a while is not to do it this method. Our goal is not to do this. So our goal after a little bit is you guys should get comfortable enough breaking things apart that you generally can look at 4x squared and 3x and figure out what they have in common without doing the factor tree. Because otherwise this method is kind of slow. I'll even write that. Kind of slow. And when you're doing bigger problems later on, it makes it harder to do a bigger problem if you have to slow down and figure something out. So there's nothing wrong with doing this method. So if you feel like you want to use this method every time, you can. I'm not telling you not to. Our goal, though, is after a little bit to not do that. How about this? I would like you guys to try this problem on your own, doing this method with the factor tree. Unless you already know the other way, and then that's fine. But try the factor tree on this problem. It works the same when there's 3 terms. You're still looking for what they all have in common and what they don't have in common. So why don't you take a minute or two, write down the 3 terms on the side, and break them down and figure out what they have in common and what they don't. And you don't have to worry about the plus or minus signs. But see if you can write it as factored, since so many people are putting these 4s and 5s up there. And maybe what I can do is I can call on people to have me break down each one of these 3 things. Alex, and you may not be done with the problem. I don't think I've called on you for a while. Do you think you could tell me how you broke down 10y cubed? Yep, okay. Perfect. That's absolutely perfect. Nice job, thank you. AJ, how about 20y squared? How did you break that one down? Oh, I think your mic might not be working quite right. Maybe you can just type it in the chat really quick, because there's no powers or anything. Close. Close. So 10 times 2 is correct, but then 10 can break down into 2 and 5. Oh, oh, you're showing me steps. All right. All right, so you broke down 20 and made it 10 and 2. Okay. Okay, good. 10 breaks down into 5 and 2. And 2 y's. Maybe you hit a 3 on accident. Yep. It's easy to do with keyboards. At least you guys are lucky. Like, I have giant fat fingers. And on a laptop keyboard, it's ridiculous trying to watch me type. So that I have to have a big keyboard to do it. Okay, so I don't know if you're done typing, AJ. You did break it down correct. The final breakdown would be 2, 2, 5, y, y, which was kind of what you wrote in there. But thank you. Ben, how about 5y? What happens if we break that one down? Maybe. All I hear is your music. At least I think it's your music. Maybe not. Okay, so to keep this problem from taking forever, 5y can't break down, and so it's just made up of 5 and y, because 5 is prime and y is a single one. And then we're looking to find what they're in common. And you should have had a 5 in common on all of them, and then a single y. So my answer for factoring is going to be 5y, and in the parentheses, I'm going to write everything that's left over, which is what they don't have in common. So I've got 2 and 2 y's, I've got 2 2's and a y, and I've got nothing, but I can't leave it blank. It's basically multiplied by 1, and you'll see why in a second. And it's kind of why I picked this example. So what they don't have in common is 2y squared. Plus sign stays a plus sign. Minus sign stays a minus sign. 1. And the reason we have to have that 1 there is if we took the 5y and then multiplied it back out, you need that 1 there so that 5y times 1 is 5y. So you have to have a 1 remaining when you're factoring out. Like if you factor everything out, a 1 stays. Okay, before we do the next problem, I'll show you the method that I'm hoping you can get to somewhat soon. And judging by the fact that a lot of people said 4s and 5s already, I have a feeling a few people already do this. So I will just start the problem over. And I'll kind of show you the method that you'd like to be able to do sooner or later. And it's not the end of the world if you can't. Like if you need to do this factor treat way every time, still works. But if I'm factoring, first thing I'm going to focus on, is the numbers. And in my head, I see a 10, a 20, and a 5. And I'm trying to think in my head, what's the biggest number that goes into 10, 20, and 5? And I think most of you are pretty good at doing that. And a lot of you can come up with 5 just from your head. Because it's not that different than common denominators. It's just backwards. And then once you do the numbers, then you focus on, I need a color that's not yellow. Then you focus on the letters. And if there's more than one letter, then you do them separately. But if I'm looking at the y's, I've got 3 y's, I've got 2 y's, I've got 1 y. And so in my head, I know they only have 1 y in common. And then to figure out what's left over, I divide by what I just took out. So 10 divided by 5 would be 2. Y cubed, y1. This is like when we did the subtraction of the powers. So this is like y2. There's 2 left. Plus 20 divided by 5 is 4. Y2 divided by y1, you subtract the powers and get y1. And then 5y divided by 5y is the same thing, so it's 1. So either of these two methods gives you the same final answer. So this is definitely why I was saying, even if you prefer the one that's a little bit slower, it 100% works. And I'm okay with you guys using whichever method. The key thing is that you just, whichever method you do it right. Have you guys seen the bottom method before? Probably then. Like was yesterday kind of ridiculously slow for you since I was showing the breaking down with the trees? I guess I didn't show it to you since most of you watched the video on Monday. Okay. Can you guys see if you can factor 12x minus 8x squared on your own? Pick whichever method you want. And it should go pretty fast once you get good at it. Murph, whenever you get done, what I was hoping you could tell me was what they have in common. And then I'll have somebody else tell me what would go in the parentheses. Yep. I don't know if you heard what I said because I got a little pop-up saying my internet went unstable. So, yep, yeah, what they have in common. They both have an X. Yep, perfect. How about numbers? What's the biggest number that goes into 12 and 8? Perfect. And then that would be considered the greatest common factor. Do you want to keep going, or do you want somebody to call? Do you want me to call on somebody to fill in the parentheses? I'm okay either way. I just figured I'd leave it up to you. Calling somebody else? Sure, no problem. Sophie? Sophie, did you figure out what should go in the parentheses? Or is this something you would like me to walk through with you? Perfect. How did you get that? But that is 100% correct. Perfect. Nice explanation. Yep, that was a bad circle. That's absolutely correct. Nice job. Does anybody want me to show this problem using the factor trees at all? I mean, I don't mind that at all. I mean, my job as teacher is to show you stuff. Teach you. Did everybody try it this way? With the dividing? In the chat, if you could give me one of two options. Could you tell me which way you prefer to do these problems? By dividing or by the tree? I mean, I really don't care which way you guys do it. I just, I would like to try to show what majority of the people are doing. Okay, I've got 4. 5, okay. And I'm hoping some people aren't putting that just to like fit in, because I don't care which way you guys do it, and neither which way is wrong. Okay. All right. So I will. It looks like most people are choosing dividing. I will try showing the dividing way here from now on. But if you guys want to see the tree way, I absolutely can. That's what I want to tell you. Like, I don't want you to feel like you can't go against the grain of whatever other people are doing. Like, it's math. You pick what you like. Okay, I want to show this example before I move on to the last topic. So sometimes you run into the case where there's a negative sign on the front one. And, some people that may throw you off, but they usually consider that like kind of like a math no-no. Don't do that if you can help it, which to me seems ridiculous, but it doesn't matter. So if you have a negative in the front or like a negative on both, what you're going to do is you're going to factor out the negative sign first. So it's like dividing by -1. So you're going to factor out the negative sign, and then everything on the inside would be opposite. And then from this stage, you would factor that. Like you're going to ignore everything written around, like the parentheses and outside. So it's almost kind of like I'm going to do 12x plus 8x squared as a separate problem and factor this on my own. So then you would take out the 4x. I think it's the same as the one we had right up there, isn't it? Oh, that was a minus, but same thing. So you would take out 4x, and you would divide both by 4x, and get 3 plus 2x. So over here, that -1, I'm going to put on the 4x. And that's how you should approach factoring with a negative in the front. You kind of take the negative out first, and then you ignore it until the end of the problem. And it's I don't know, it's kind of a dumb way, but I mean, it works. Like, most people find that to be a better method. Okay, here's the last topic. They look way worse. If you have something that has 4 terms, so I have the steps written on the side. I'm hoping it's not too sloppy for you to read. If you want me to translate, I can. It's called factor by grouping. So if you have 4 terms, there's kind of a method you have to go through. So in your notes, it would definitely be better to kind of, have them written down. Okay, you probably have the steps written down by now, I'm going to guess. So step 2 is you're going to split it in half. Now, what that means is you're going to make an imaginary line. And this imaginary line is us looking at the first half, looking at the second half, and we do them separately. So that's what this means when it says factor each half. So I'm going to look at 12a cubed minus 9a squared. Okay, so 12 and 9. Actually, maybe I'll just call them people here. Ella. And if you're catching up on writing, like maybe I went too fast, just let me know. Ella, are you kind of at the stage where I'm at? Okay. I just didn't want you like trying to scramble to catch up like I was. Okay, so I'm looking at 12a cubed minus 9a squared. What's the greatest common factor? Like, what goes into both? What's the biggest number? We'll start with the numbers. 3, perfect. How about letter-wise? How many close. There's going to be 2 of them. So since a cubed is like a squared is like a and a, they both have 2 in common. So that's going to be my greatest common factor. And then I'm going to figure out what would be left. Okay, Ella, do you want to tell me what would be left, or do you want me to call on somebody else? Okay, I can certainly do that. Thank you for your help. Gracie? Gracie, do you think you could help me fill in the parentheses? Perfect. Perfect. There's 1 A left over in the beginning, and there's no A's left over in the second one. Perfect. Okay, so this is, this is the first half. We do each half separately. Okay, now I'm going to do the second half. This plus sign kind of just sits there, like, it's kind of weird, but I get it. Now we're going to figure out what 20A and 15 have in common. And do know it's entirely possible they have nothing in common. You're going to get examples like that. So 20A and 15, they don't have any letters in common because the second one doesn't even have a letter. So it looks like 5 is the only thing that goes into both. So I'm going to divide each by 5. And then I would get 4A and then 3. Now, if you did this correct, you'll know right away if you did the problem right or not. If these 2 parentheses are the same, then things went correct. The 4th step says common factor each half. Oh, well, the first half and the second half each have the same thing. So they each have a whole parentheses that's the same. So I'm going to put the whole parentheses first, because the whole parentheses is what they have in common. And then, Sadie, do you remember what I'm supposed to put in the parentheses right here? What was that information again? Like, what did I call it at the very beginning? Oh no, I mean, I do get that. This actually does 100% look like foil. I didn't even think of that right now. The second parentheses is going to be the information that's not in common. So, like when I'm looking at the first half, this stuff was in common. This stuff was not in common. So I'm going to put that in the second parentheses. And it looks really weird, but we were able to take this big, huge... Actually, I don't like that as much. Let's do a highlighter. I like highlighters better. Come on. This big, huge problem, we were able to factor. And now this is written as 2 binomials. Now, maybe I should go to Sadie for this question. Sadie, if I wanted to check if I did this problem right, what could I do? Since you've got it on top of your mind. Yep. Yep. Here, I thought you were going to just type it again. So if I wanted to FOIL these out, I could check to see if I did it right. And I'm not going to FOIL it. I'm just going to tell you we did it right. Like, it takes a lot of extra time to do that. These go really slow, and I 100% get that you'll be annoyed with them. But the good thing is that these steps work every time. Okay, what are we on? We're on 35 minutes. Okay. I don't think, yeah, okay. Let me put this right here so that you can see the example right above it. Why don't you guys try to factor 9x cubed plus 18x squared plus x plus 2? And if you get stuck at a step, that's fine. I'm actually fully expecting some people to get stuck. So I'm going to I want you guys to at least start it. See if you can figure out the beginning. I'm going to guess that some people are stuck right away on the second step. So I kind of want to semi-interrupt to try to help you out with that. I'm going to guess a lot of people figured out 9 and x squared is in common. And if you divide by 9x squared, you get 1x. So I'll just write x. Plus 2 no x's. I bet a lot of people got that. And then the second half, did anybody figure out how to write it when they have nothing in common? Because x and 2 don't have anything in common. Perfect, Desmond. So x and 2 only have one thing that multiplies into both of them. So it's a 1. Like, and nobody ever writes that. It's just, but both of them are multiplied by 1. So if they have nothing in common, you put a 1. And like, if you want to divide by 1, go for it, but it's the same thing. And that works out good for us, because both of these parentheses are the same then. Who have I called on? Isabella? Isabella, I haven't called on you for a while. Do you remember what to do next? No, it's all right. Do you remember what to do next? Like, how to... Yep. Perfect. Basically, you look for the stuff that didn't get used. The leftovers. Excellent. Excellent. Okay. I have a feeling if I asked you guys how this is going, it'd probably be like, I bet some people, it would range from 2s to 5s. Okay. That's usually what happens on this method. And it's not like each step is individually bad. It's just, it's really hard to remember all these steps. So I'm hoping you guys have the 4 steps written down. I can go back up if you need me to go back up to that. Or actually, let's be computer smart. and then I don't have to write it again. I wanted to show you this last example and then we'll be done. Okay. Sometimes you're thrown trick questions. Sometimes you're thrown trick questions and it's really annoying. And as somebody who's trying to teach you this hard method, I don't like how that you get thrown trick questions. So I want to show you the trick questions if you see them. So this particular example, I did the first step for you. And when I did the first step, I feel like something went wrong because the parentheses are not the same, but I wrote above them, kind of the same. They're kind of the same because they're reversed. Like it's the same information, but written reversed. So here is the math trick that you can do. If you want to flip a parentheses the other way around, take out a negative symbol. And then you can flip it around. Now, it seems totally wrong, like it feels like you're semi-cheating. But it works out. Because if I take the 2 and multiply by the 5, I get 10. And if I take the 2 times the negative x, I get negative 2x. And if I do that down here, I still get the same information. So it's kind of a, trick move, whatever we'll call it. It's a way to manipulate your information. So if you want the information to be written in reverse, you take out a negative symbol and then you can write them in reverse. And by us doing that, now they are the same. And once they are the same, then you can write the final answer. Oh, also, nobody's asked me this yet. It doesn't matter which parentheses you put first or second. Because usually every time I teach this, somebody likes to write the uncommon information first, and then the same information second. That's fine. Either one is correct. As long as your parentheses has like the same information. The order of the parentheses doesn't matter. Okay, that's what I got. Obviously, I'm going to assume that the second half of your homework is going to feel harder to you, and I bet some of you it's fine, and some of you are going to have a hard time with it. I'd actually recommend that you guys do the harder problems first in the homework, and then when you go back to do the easier one, it's going to feel like you're doing almost nothing. But so I'd recommend you do the harder ones first because it's probably fresh in your head. So let me stop the recording here so that I can look up the info if you guys need me to for you.